Okay, well, welcome to SVIP Demo Week here. This is actually our fourth time here as well. I'm Alan Kenny, as Ron said, founder, CEO of Kenautics Incorporated, and we're honored to be moving into a phase 4 with SVIP on what's called the Maritime Object Tracking Technology, or MOT. So what is it, why, and how does this work? It is basically an air-deployable floating buoy system that can be thrown out of an aircraft, helicopter, cutter, or small boat. And its primary purpose is for drug or contraband interdiction. So some of you may know square grouper, which is essentially deployed drugs overboard, spills, oil spills, hazard or debris fields. And so how do we do this? We take a bunch of highly sensitive electronics, AIS, which is the automatic identification system used for maritime vessels, similar to an aircraft, radios, white and infrared strobes and sensors, processors, batteries. We take all this and we put it into a plastic container like this, or other variants of it. We throw it out of a plane or a helicopter, let it splash down, and basically live in the water for multiple days at a time, if necessary, hopefully only a few hours, and then we communicate with it. The communication is basically tracking of the objects in the water, but it can also be operated in an overt or covert mode using encrypted communications, or totally passive, just monitoring, tracking, and logging the information. Our goal is to recover this and hopefully the object that we are tracking as well, and then do it again. So to do that, you need a very ruggedized plastic device to keep all these electronics in, to be able to survive in those environments and to be able to communicate with it. So here is an example of deployment of these during the phase 3 testing. So essentially you take the device, potentially add a parachute depending on the altitude and speed. In this case, we're in a C-130. We have a location where we want to drop it. Pilot gives it a drop, drop, drop. Away it goes. Second one with a parachute. Third one here without a parachute. And drop. When this hits the water, which it will right now, that basically turns on the transmission of the sensors if they are in an overt mode, at which point you can be either encrypted or non-encrypted, tracking the device. So here we're at the Coast Guard station. We happen to have a video of that same deployment, and we are tracking the location of that. Sample here out of a helicopter during some of our testing, 350-foot drop from the maritime perspective, from the boat perspective into water. At that point, the sensors turn on and start tracking. Sitting in a car here in an overt mode, I am listening to the Morse code and or audio tracks that are being transmitted from the device as a radio direction finding beacon. And in this example, a commercial AIS tracking the device. In this case, that was from our lab, so the location looks like it's on land there. But that's commercial AIS so that you can be tracking it. So how did this all occur? We started out as a company in 2015 building a diver navigation system for special forces, imaging, communications, et cetera. And in 2020, we met Melissa at a Coast Guard Center of Expertise kickoff at Scripps, telling us about SVIP. We've noticed that the MOT tracking capability was a perfect fit for our technology and our sensor fusion capabilities. Use cases, again, as mentioned, were contraband interdiction. We found that we could fit a lot of other applications as well. So in the MOT, we have these sensors, AIS, radio modem, and strobes, but we had a lot of other capabilities within the technology, including cameras, listening devices, et cetera. So we brought this and we made a variant of this for SOCOM, including acoustic modem and MANET mesh network, to be able to put this into a tactical environment. And we're now one of the 40% that's gone on to another government contract with the Army to be able to use that capability and communicate for biometric sensors, wearable sensors. Next step is to put this into be able to communicate with underwater vehicles. Our growth path, adding new sensors, taking our sensor fusion capabilities and adding those, implementing AI at the edge with these sensors. We have invested so far about $2.5 million on our own to develop these technologies and are looking also for additional investment partners, major partners and integrators, especially collaborators working with the DoD and DHS. And with that, thank you very much for listening, and we will take questions.
All right, so I'll jump in real quick. And I have to recuse myself a little bit because I was one of the people that started this back in 2016, 2017, back at Coast Guard. And we started with a lobster float and a dog tracking collar, a tile. But that's a great point for this group, right? Because, we want you to come to us. We have a lobster float and a dog collar, and we don't know how to get it to the next level. So we need you to come to us and say, hey, we can handle that for you, and we can make it commercially viable. And that leads me to my question. This is kind of a specific technology, but since this has started, a lot of the other components have come to us and said, hey, we can use that for all kinds of different things, for tracking after natural disasters with FEMA and other agencies and things. So what is the commercialization strategy? You know what I mean? How are you going to put this out, and what quantities and volumes and ramping up production? And I know it's a lot to ask, but
yeah, it's an involved question, but basically it comes down to this key point with the additional use cases. Meteorological applications, CTD and ADCPs, which are basically looking at current profiling, data relay of subsea communications, oil and gas applications for being able to communicate with divers and salvage operations or underwater construction, cases for surveillance, listening devices, and camera optical surveillance, and then ocean and maritime research applications. We have a path defined for pretty much all of these. Our first foray into this is with the Army Special Forces for a diver training application, and what we've done to integrate it to the Tactical Mission Network, the ATAC network for SOCOM. Those are first steps.
Great. So let me preface this by saying I'm over-caffeinated. I love Shark Tank, and I'm the least tech-savvy person in this room, undoubtedly. So bear with me, everybody. But just curious, what was your most recent or largest unanticipated technology issue? How did you overcome it?
The biggest issue, I think, was combining in a variant of MOT where we put in the acoustics with the RF. We had a lot of issues in terms of the application, how to get all this low speed information into something that wanted high bandwidth, high speed information. In the case of the MOT, it really got down to more the autonomous buoy versus the operation of the buoy in the aircraft, because the RF created interference issues, just technical challenges there on interference and other that we had to overcome to make sure it could always operate with or without the RF, and being able to do it in both the covert, overt, and encrypted methods.
So one, I really appreciate that you showed the video of the C-130, right? True Lockheed. So can you talk a little bit more about your business model? I'm assuming, being a hardware-centric platform, you are selling the actual hardware to your customers. Do you have any type of subscription model for the software that comes with the AI you were talking about, and how are you going to approach the data side?
Yeah, it's largely a collaborative model, because we're collaborating with actually a company that we met through the first SVIP demo week for integrating AI at the edge on the sensors. And so we started putting that into our diver systems and used the MOT to relay that data up. From the business model perspective, we're trying to define those applications both in the commercial and DoD space, because we largely work with DoD and have been focusing there. But our next step is moving that into those oil and gas applications and the ocean research applications as well, because they all have the same needs from a technical point of view, different application point of view. So we're branching out in essentially those three spaces. I hope that answers the question. All right, well, thank you very much.
Thanks, Alan.
Turn it back.